But first, the humble battery. Last year, the UK used more than 680 million of these little tubes of power. But how do they actually work? These cases are for the standard AA battery. But what else do you need to make one? A battery consists of a case, a positive pole, a negative pole, a base plate, and a pin to allow the electricity to flow around the circuit. It's hard to believe that a small tube with a sticker on it powers so many household devices. They're used in everything from remote controls to MP3 players. But have you ever wondered how they work? We've established batteries have a positive and negative pole. The negative pole is full of electrons which are all trying to escape. Electricity is the force used when they move from a negative pole to the positive one through an electrical circuit. The materials used to make the positive pole are manganese dioxide and graphite. You might be familiar with graphite as it's used to make the pencil. The positively charged mixture works by absorbing electrons that pass into it. It gets pressed into rings which are then inserted into each battery case. The more that can be put into each battery, the longer that battery will last. The mixture is loaded into the top of the machine here, and once it's compressed, the rings are then loaded into each battery as it passes below. For the battery to work, the positive and negative poles must be kept apart. A rubber-like material is rolled up and used to create the internal barrier that does this. This high-speed machine then inserts each individual roll into the batteries, which are already lined with graphite. To show you how it works, we've had to have the machine stopped. The lining is highlighted here in red. As the batteries come out of the machine, they've slowed just enough so you can see the white lining in each case. Like yin and yang, a battery is made up of two opposites. They have both a positive pole and a negative one. We've got the positive. Now we need to make its opposite by combining zinc powder and a gelling agent. The mix is very toxic though, so a machine is used to minimize human contact. The combination creates this gloopy substance, which is a negatively charged gel. Once it's fully combined, this is added into the lining in the battery cases. We've now got the two sides to the battery, but to make them work, the electricity needs to get from one side to the other. If the electrons can't travel between the poles, the battery won't power your remote. So to get round this problem, the clever guys at the battery factory have come up with a solution. That's where these base plates come in. Although it's normally used for the road surface, each plate is loaded with a squirt of bitumen. It makes an excellent glue. Brass pins are then introduced, and this is the secret to how the electrons can get out. They travel down through this pin and into your remote or any of the hundreds of devices that are powered by batteries today. You can now use them to help you switch channels, light up your torch, or power your MP3 player. When their job is done, they'll head back through the wires into the positive pole in the battery. Once they've been assembled, the plates and pins are fed into this machine, and a hydraulic press squeezes them into the waiting case. They're now complete, although at this stage they don't look like the batteries you would recognize. Before they receive their trademark stickers, they're all tested. If the battery's lining is damaged, then it short circuits and won't give out any power. This machine tests each one and removes any of the faulty ones, so you're not left frustrated and powerless. Rolls of stickers are loaded up and attached to the batteries. And now they're complete. So next time you're crashed out on the couch with the remote control, spare a thought for the electrons that are saving you from getting up.